Hi there, folks. Today we're looking at the quadratic formula. This is the next method for solving quadratics that we're going to do. And it's really the kind of catch-all method. You could use the quadratic formula every time. I certainly wouldn't recommend that. I would always check factoring and then move on to the quadratic formula if factoring doesn't work. Okay, and we'll see an example that could be solved by factoring that we'll solve using the quadratic formula, just to compare the two in terms of the amount of work that you have to do. Completing the square is a really nice method for when a is 1 and b is even, but the quadratic formula kind of picks up where that leaves off. And really, the quadratic formula is just a rewrite of the equation ax squared plus bx plus c after we complete the square. So let me show you where the quadratic formula comes from. If I generically have ax squared plus bx plus c equals 0, and I were to solve by completing the square, the result will be the quadratic formula. So let me show you this real quickly. And I'm not going to expect you to derive this thing, but I want you to see where this comes from. So the quadratic formula here, again, is x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And really, the nice thing about the quadratic formula, what it does for us here, is it just allows us to take the values from the equation, the a value, the b value, and the c value. Remember, ax squared plus bx plus c. A is just the number in front of x squared. B is just the number in front of x. C is just the number by itself. And so I can take those three values and just plug them into this formula, and I can get the answer by simplifying. All right. For example, if I look at this first guy, and keep in mind, when I see this this symbol right here, I call that the opposite of b. Some teachers and some students will say negative b, but really that symbol is an opposite symbol. We call it a negative when it's in front of a number because, well, that's what the opposite of a number is. It's a negative number, okay? But we don't know if this b value is going to be positive or negative yet, all right? We simply say it's going to be the opposite of b. So when I look at this first example, the b value here is a negative 4, which means the opposite of b is a positive 4 for my equation. And then plus or minus the square root. And then b is a negative 4 squared minus 4 times a, which is a 1, times c, which is a negative 2. And the signs here become really important. You have to make sure you keep the sign with that value. All over 2 times a, which is also a 1. And again, I'm just reading those off of this equation. There's the 1, the 4, and the negative 2. It's a, b, and c written out for me when it's in this format. Okay? So I just plug those in, and now it's just time to simplify. So x equals this thing. And now I simplify this until I have a simplified version of this thing. I just start plugging away. So inside here, I always do this in the same couple steps. I always square this guy. That's a 16. And then in the same step, I multiply out the 4, the 1, and the negative 2. And just be really careful with the signs here. You can think of that 4 as a negative 4 and just say negative 4 times 1 times negative 2 is a positive 8 and write a plus 8 down here. Or you could just say 4 times 1 times negative 2 is a negative 8, but then keep in mind it's minus a negative 8, which is adding the opposite, so it's a plus 8. And then that's all over 2. And now the next step, I simplify what's under the square root by adding it together. That's a 24. Now I simplify the square root the same way I always simplify the square root. 24, that's 4 times 6. The square root of 4 is a 2. The 6 is still trapped. And again, take that off to the side if you need to, all right? Hopefully you're getting close to being able to do that in your head, but if you're not, take it off to the side. And now the last thing I can do here, because everything's divisible by 2, all those outside numbers, I can use my distributive property. That's a 2 plus or minus 1 root 6 by just dividing each of those. 4 divided by 2 is the 2, and then 2 root 6 divided by 2 is just the root 6. Those are my two answers. And once again, they're answers that I would not have been able to get to by something like factoring, all right? However, this is an answer I could get to by completing the square. Completing the square wouldn't have been too bad for this one. And so you kind of have to make a judgment call in terms of, well, would completing the square have been easier for me for this one? All right, do I understand it well enough that I can use it when the a value is 1 and the b value is even? The fact of the matter is completing the square requires a lot less simplification, especially in terms of the square root. Okay, I think completing the square is easier for this example when the a value is 1 and the b value is even. But you might disagree, and that's okay, all right? You could use the quadratic formula, but you have to make sure you simplify it all the way to the end, okay? Simplify it as much as possible, all right? If I look at the next one, same kind of thing here. Once again, this is not written properly, if I think about it. I have to subtract that 6x from each side, okay? I got to have this thing set equal to 0. And then the other thing here, make sure you write this in the appropriate order. It should be 3x squared minus the 6x plus 2 equals 0, okay? Make sure you write that in the appropriate order. It should be the x squared, then the x, then the constant term. That's in the right format for identifying a, b, and c. And now, opposite of b, so b is a negative 6 here. So the opposite of b is a positive 6, plus or minus the square root, b squared minus 4 times a times c, all over 2a. And now I continue to simplify. Again, here's my couple steps that I always do. And notice, consistency makes these a lot easier. I square this guy at 36. I do the multiplication here. That gives me a negative 24 over 6. And now let's subtract what's inside there. That's going to give me a 6 plus or minus the square root of 12. That's 4 times 3. The square root of 4 is a 2. The 3 is still trapped all over 6. And now I can reduce. They're all divisible by 2. So this becomes 3 plus or minus root 3 over 3. Okay, that would be an acceptable answer. Or if you completely split it up, you would do 6 divided by 6 and get a 1. And then you would do the 2 over the 6 and get a 1/3. All right, so if you wrote your answer like this, if you did this, 1 plus or minus root 3 over 3, that would also be an acceptable answer. And that's what you would get if you literally split these up into 6 over 6 and then the 2 root 3 over 6, okay? And again, that is a great way to do this, all right, if you're worried about forgetting to reduce this thing all the way, okay?